You learned it as a child. Sugar causes cavities. It is on the posters in every waiting room. It is the first thing most of us are ever told about our teeth. And it is not wrong. But it is one of those sentences that is just true enough to stop people from asking the more interesting question. Because if sugar simply caused cavities, then everyone who eats sugar would get them, in the same way, on the same teeth. And that is not what happens. Two people can eat almost the same diet and end up with completely different mouths. One brushes no more carefully than the other. One is not obviously doing everything right. And yet, year after year, one keeps developing cavities and the other barely does. And here is the question I find myself asking in the clinic almost every day. Why does one tooth develop a cavity while the tooth right next to it, exposed to the same saliva, the same sugar, the same brushing, stays perfectly intact? Are the bacteria choosing teeth, one by one, on purpose? They are not. And the answer to that question is what this entire episode is about. Because a cavity is not something sugar simply does to a passive tooth. It is the visible endpoint of a process, and that process has more than one author. Let us start with the version we were taught, because part of it is real. Your teeth are not sterile. They are covered by a living film of microorganisms we call the biofilm, or dental plaque. Many of those microbes are harmless. Some are even useful. But certain species do something specific when you eat fermentable carbohydrates, and that includes sugars, but also refined starches. They metabolize those carbohydrates and release acid as a byproduct. That acid lowers the pH right at the surface of the tooth. And the moment that acid challenge begins, another character enters the story. One that regular viewers of this channel already know well. When the local environment becomes acidic enough, minerals, mostly calcium and phosphate, begin to dissolve out of the enamel. This is called demineralization. But here is the part the poster always left out. The process is not a one-way street. As soon as the acid is neutralized, saliva goes to work. It buffers the acid. It brings the pH back up. And it carries calcium and phosphate back into the enamel. That is remineralization. Your mouth is quietly repairing itself many times a day, every single day of your life. A cavity does not appear because demineralization happened once. It appears when at one specific spot, demineralization repeatedly wins against remineralization over months and years until the surface finally breaks down. So even in the classic model, sugar is not a villain acting alone. Sugar is the fuel. The acid is the weapon. And the real story is a balance, tipping slowly in one direction or the other. So, why one tooth and not its neighbor? For decades, the textbook answer was a single bacteria, Streptococcus mutans. Find the bug, blame the bug. But the science has moved well beyond that. What the evidence now describes is much closer to an ecosystem than to a single culprit. In one study that followed children from infancy, researchers found that the composition of the whole oral microbial community could predict which children would later develop caries, before Streptococcus mutans was even detectable. The balance of the entire community mattered more than the presence of any one species. And, notably, certain protective bacterial groups were linked to a higher salivary pH. This is what is often called the ecological view of caries. Disease does not begin because one evil microbe arrives. It begins when the local conditions, frequent acid, low pH, low oxygen, push the whole community toward the acid-loving, acid-producing species, and away from the ones that keep things in balance. We call that shift dysbiosis. And this is exactly why bacteria do not choose teeth. The mouth is not one uniform place. It is dozens of microenvironments. A deep groove on a molar traps biofilm and shelters it from your toothbrush and from your saliva. The tight contact point between two teeth is hard to clean and slow to clear. Those sites sit at a low pH for far longer after every meal. The smooth, well-cleaned, saliva-washed surface right next door recovers in minutes. Think about what that means for two neighboring teeth. One has a deep, sheltered fissure where biofilm sits undisturbed and the pH stays low long after you have finished eating. The other presents a smooth, exposed surface that saliva bathes and a toothbrush reaches with ease. They belong to the same person on the same day, eating the same food, and yet they are living in two completely different worlds. Same person, same sugar, a completely different local battle. The tooth that loses is not unlucky. It is simply the site where the balance was hardest to hold. But there is a second half to this, and it is the half that classical dentistry has historically underplayed. We have talked about the attack, the acid challenge. We have said almost nothing about the defense, because not every tooth shows up to that fight equally armored. Enamel is built before the tooth ever erupts, and that construction can be imperfect. There are well-documented developmental conditions, such as enamel hypoplasia and molar incisor hypomineralization, where the enamel forms with less mineral than it should. These teeth erupt softer, more porous, and more vulnerable to exactly the acid process we just described. The weakness is in the building material, not in the bacteria. This is where mineralization becomes genuinely interesting, and where I want to be precise, because the evidence here is suggestive, not settled. There is growing research interest in vitamin D, which is central to how the body handles calcium and phosphate, the very minerals enamel is made of. Several meta-analyses have reported an association between low vitamin D status and a higher risk of caries in children, and some work points to the prenatal window as well. But let me be clear about what this does and does not mean. It does not mean caries is simply a vitamin D deficiency, or that a supplement will reverse a cavity that already exists. The evidence is associative, of low certainty, and far from conclusive. What it does support is this: the tooth is not a passive target. Its resistance is influenced, in part, by developmental factors, by nutrition, and by how well it was mineralized in the first place. So when I see a cavity, I am not only asking what attacked this tooth, I am also asking why this particular tooth was less able to defend itself. None of this lets sugar off the hook. It simply puts it in its place. Because when you zoom out from the single tooth to whole populations, the link between sugars and caries is one of the most consistent findings in all of dental research. The systematic review that informed the World Health Organization's guidance and its 10-year update found that caries is lower when free sugars are kept below 10% of total energy intake, with a further benefit below 5%. The authors graded that as moderate quality evidence. There is a dose response. Broadly, across populations, more free sugars means more caries. But notice the words that keep returning: free sugars. And notice what the mechanism told us earlier. It is not only how much, it is how often. Every time you eat or drink something fermentable, you begin another acid cycle, and you reset the clock on your saliva's repair work. 6 sweetened coffees sipped slowly across a day keep the mouth acidic far longer than the same amount of sugar taken in a single sitting. Frequency is the quiet variable that almost nobody counts. This is why that matters so much. After a single exposure, it takes time, often somewhere on the order of 20 to 40 minutes, for saliva to neutralize the acid and bring the surface back toward balance. One meal, one acid cycle, one recovery. But if you are grazing all day, a biscuit here, a juice there, a sweetened coffee an hour later, you begin a new acid cycle before the previous one has finished healing. The tooth never gets its recovery window. The same total amount of sugar, delivered as a constant trickle, keeps the surface under siege in a way that a single dose never would. This is one of the most useful things you can take from this entire episode. It is not only about cutting how much, it is about protecting the gaps in between. And we should be honest about the quality of the evidence as well. A recent review commissioned by the World Health Organization found that nearly all of the studies linked sugary foods and drinks to caries, but also that more than 2/3 of them carried a serious risk of bias, with very mixed methods. The direction is clear, the precision is not. That is the honest scientific position, and it is far more useful than false certainty. So let us rebuild that childhood sentence. A cavity is not sugar acting on a helpless tooth. It is the outcome of a balance, fought at one specific spot, between an acid challenge and a defense. On one side, fermentable carbohydrates, how often you eat them, an acid-producing biofilm, and a low local pH. On the other side, saliva, time to recover, and the mineral quality of the tooth itself, built long before it ever erupted. It still matters enormously. But so does frequency. So does the ecosystem living on your teeth. And so does whether the tooth was well built and well mineralized in the first place. Caries connects to the rest of the body precisely because it sits at that intersection where diet, the microbiome, and mineral metabolism all meet. That is also why oral health rarely travels alone, and why the same dietary patterns that drive cavities tend to track with broader health over a lifetime. And this changes what prevention even means. If a cavity is a balance lost slowly at one single site, then prevention is not one heroic act once a year. It is dozens of small things that tilt the balance back day after day. How often you eat, what you feed the ecosystem on your teeth, how much you let saliva do its quiet work, how well the tooth was built in the first place. None of those is dramatic on its own. Together over years, they are almost everything. That is why two people eating the same sugar can end up with completely different mouths. And it is why prevention is never just one thing. It is reducing how often the challenge arrives and strengthening how well you are able to answer it. The bacteria were never choosing teeth. The conditions were. And the moment you understand that, prevention starts to make a lot more sense. Pay attention. Your body already is.